Hello, loyal YouTube following. Game plan for today is to go over the 4 ways to solve a quadratic equation, talk about which strategy is best when, what are the pros and cons of each strategy, and then how do you do each of those 4 strategies. So for starters, when we talk about doing a strategy, we're talking about solving for the x's that make the function equal to 0. So we're solving for the zeros of a function. In a graph, those are pretty easy to see because it's where the graph hits the x-axis. So in this situation, maybe our zeros would be like x equals 1 and x equals 5 or something. And you would write out those solutions as x equals 1 and x equals 5. You could also write it as x equals 1 and x equals 5, x equals the set of 1 and 5. Any of those would be good. You can go with the x equals 1 or x equals 5 using the inclusive or, meaning or slash and. But I'm happy with any of these. I usually default to this one because it's the fastest and easiest to write. Anyway, which strategy is best to use when? So what I've built over here is a little matching game. So if I were given these 4 quadratics, I don't know, maybe on a quiz or something, and if I were given these 4 strategies and I had to use each one once to solve those quadratics, I don't know, maybe like on a quiz, here's what I would do first. I would first look at factoring. Factoring is the most specific in terms of when it can be used because we need numbers that fit nicely into these boxes that make the equation work. So when I'm looking at these functions here, or looking at these equations here, that looks ugly. That looks kind of ugly, but at least like 2 and 125, like there's some multiples there, not together, but like 2 and 5, like there's some nice stuff. But those are ugly, so I would start up here. I would probably not look at this first because there's big numbers, even if I notice that they can all be divided by 8, which is great. But I would probably start with this one first. I would be looking at what 2 numbers can multiply to get 40 and add to get negative 14. Some of you that's really fast, some of you that's not so fast. If it's quick for you, then you might have seen negative 10 and negative 4 pretty quickly. If you did, that's fantastic. If you didn't, that's totally fine. I'm going to go more in depth on factoring in a little bit. So factoring, I would use that one because it works nicely. So going into the quiz tomorrow, I'd probably try and identify factoring first and use that early because it only works nicely when the numbers are pretty clean. So factoring I would use there, and you would have x minus 10 times x minus 4 equals 0, and therefore either x minus 10 equals 0 or x minus 4 equals 0. Both are possibilities. So then x equals 4. That's a positive 4. Sorry, it's a new iPad, so I'm struggling here. And x equals 10. And those would both be your solutions. Next, completing the square is the next one where you have to kind of have nice numbers because for graphing, you can jam whatever crappy equation you want to in the graph and it will still build it for you. Same with quadratic formula, you can cram crappy numbers into the quadratic formula and it'll still work. But with completing the square, things have to kind of work nicely. So again, I would avoid these ugly looking ones and I would start to look at this one. Especially since the nice thing for completing the square is you want this C value on the other side. Whereas for graphing quadratic formula and factoring, you want them all equal to 0. So let's see if completing the square works here. First, I'm going to divide everything by 8 because I want just a regular x squared. That is, I want the a value to be 1. Now that I have divided by 8, I'm going to split this value into a perfect square. Specifically, I'm going to split it into x minus 2 squared because I know when I do x minus 2 squared, that's x minus 2 times x minus 2. And that would expand to be x squared minus 2x minus another 2x plus 4. And after I combine my like terms in the middle, I will have this, which is great because it really matches up with what I wanted here. because I wanted to rewrite this in a different way that was a perfect square. But you might recognize the issue here. I have x squared minus 4x, and I got that. But I also got a plus 4 stuck onto the end. So because I accidentally added 4 to this side in order to build my perfect square, I made up for that by adding 4 to the other side too. So even though you don't see the plus 4 on the left, that plus 4 exists. Erase. That plus 4 exists because when this is expanded out, it'll be x squared minus 4x plus 4. And there's a plus 4 baked into this perfect square that you can't see. As a result, I added 4 to the other side to keep the equation balanced because I need it to be equal. Continuing. I can combine these two numbers on the right. 5 plus 4 has always been 9. And so now we have a full side of the equation that's a perfect square. The nice thing about that is that the square root can knock out that squared because square root's the power of 1/2. And we're left with x minus 2 equals plus or minus 3. Because the square root of 9 is 3. And also the square root of 9 is negative 3. And so that's where we're going to get our 2 zeros, just like before when we got 2 zeros. I can solve those tiny equations while running out of room, and I will get x equals 5. And I will get x equals, that's a positive 2, x equals negative 1. So my answers would be x equals 5, negative 1. Those would be my two answers. Now to be clear, that is not one coordinate. That is a list of numbers that x is equal to make the function 0. Okay, I have now completed the square and factored, and I've used up the top two equations. Next would be graphing and quadratic formula. Here's something that I haven't said in class that I think will be helpful for tomorrow. If you don't know it, you could still be totally fine. I would personally try graphing first. Graphing will work no matter what. The only problem you might run into is that you might graph an equation and get an answer like 2.715623189. That's a 9. If this happens, your calculator ran out of space to put numbers, but it was probably trying to give you an infinitely long decimal that never stops and never repeats, aka an irrational number. Now, to be clear, this has nothing to do with the problem that's right here. This is just me giving an example of what your calculator might give you that would tell you graphing may not have been the best choice there. Because if you get this irrational number, what probably happened is you took the square root, or the calculator took the square root, of a non-perfect square. As a result, it had to give you this giant ugly answer that at some point got rounded, and so you no longer have an exact value. If you get something like this by graphing, that's your cue to use the quadratic formula. If you use quadratic formula, you will always get beautiful answers, and the world will smile upon you. Okay. I'll go into solving with graphing and quadratic formula in a moment. You'll be given the quadratic formula on the quiz. Some of you have already memorized it, which is awesome. But again, you do not have to have it memorized because you're going to be given it. For graphing, I would graph both of these. One of the answers will be nice. It's something like, I want to say this one's like negative. I'm going to be wrong. Some parent's going to look this up and be like, he can't do math, but I can do math, I promise. I just can't do this in my head. It's something like this. I don't remember off the top of my head. But regardless, you'll get answers that are reasonably nice. Like, I didn't have to do any rounding here. I expressed one as a repeating value. But again, irrational numbers are non-terminating, so non-ending, and non-repeating. So it's okay if they repeat. For the other one, you're going to get a bunch of gobbledygook, and it's going to be nonsense, and the numbers are going to be totally out of control. And that's your sign that you should use the quadratic formula, because then you can leave it in exact form, and it might look something like this instead. And you can leave it like that instead of using this ugly decimal equivalent. Okay, continuing, the good and the bad. So, the good of graphing is that it almost always works, even when equations are pretty ugly. The problem is it won't give you exact solutions. So like in this equation I talked about a second ago, if you were graphing and got that, it didn't work for an irrational number. You would have to round that. So it will not give you exact solutions when the zeros are irrational. And if numbers are very large or small, the window can get tricky. So think about how many times you've opened your graph to see a graph and you just see nothing. And really it's because you're seeing this section of the graph, but the graph is like way over here or something and you just can't see it and you have to mess with the window to find it. That's the only other downside of graphing, is sometimes the calculator window can make it difficult to see. Or if it was super tiny, maybe it would look like that and it could secretly be that it crosses the x-axis there and there, but it's just too difficult to see. So that's the only other downside. It's also what you've done the most, and people seem to be really comfortable with it. And I'm confident with you guys doing it. So I would do that for almost every problem, even just to check yourself. And then it's visually helpful, especially for no real roots, because if you see something like this, you won't have to deal with like the square root of any negatives where you have to figure out it's no solution. You guys are pretty strong at visually being like, it doesn't hit here, so there's no real roots. It's not possible for this to hit the x-axis because it literally doesn't. So that's another positive of graphing, is it's visually pretty clear when there's no real roots. For completing the square, here is the only good thing about completing the square, besides the fact that it gave us the quadratic formula. So thank you, completing the square. The only good thing is that we can find the vertex. If you had this equation here, you could find the vertex of it by completing the square. I split the negative 12 in half to get negative 6. And so negative 6 times negative 6 is positive 36. So to be balanced, I'd add that to the other side too. And now that I'm here from negative 27 plus 36, I moved the 9 over to the other side by doing negative 9 or minus 9 to both sides. And so that leaves us with the equation looking like this. It's the same equation we started with. It just looks way different now. And that can tell us pretty quickly that the equation was shifted 6 to the right and 9 units down. So 6, negative 9 would be the vertex. So the other way would just be to graph it and calculate the vertex. But if you ever wanted to do it by hand, completing the square is your go-to. Other than that, it's only really helpful for vertex form. And it's the only method where you need C to be on the other side instead of with all the other numbers in standard form. So that's kind of weird. Quadratic formula, this is S tier. If you could only do one way of solving a quadratic for the rest of your life, this is the move, because it always works, even with irrational numbers. This is the one you want. This is your go-to. Whatever the hardest problem is, probably do it this way. It's not very number crunchy. You jam everything in your calculator and click enter, and then you go back up and you copy what you typed in, change the plus here to a minus, and then click enter again. If you get no real roots, it will tell you that. It'll say no real answer. That's it saying, oh, you got a negative as the discriminant, and we can't take the square root of a negative number, so therefore there is no real answer. Downside, it's very easy to make a calculator mistake and not realize it. So like typing in a minus instead of a negative completely throws your answer off. Missing a number or missing an exponent totally throws your answer off, and they're really easy mistakes to make. And then secondly, it takes a while to type it in because that's kind of annoying. But in general, quadratic formula is the best. Factoring, though, is the most fun. So number puzzle fun, happy face is how I feel about factoring. It's fast for the easy problems, but if you have a more challenging problem, it can get really tough to find the numbers. So like if I gave you this, I guarantee you there are two numbers. They're probably disgusting decimals, but I guarantee you there are two numbers that multiply to get negative 1,000 and add up to negative 17. I have no idea what they are, but I guarantee they exist because I know the graph is going to look something like this with a huge scale. So it's going to hit the x-axis. So some factors exist, but it can get really tough when the numbers aren't nice. It's a little easier to understand why it works than completing the square quadratic formula, because you have two things multiplying to get 0. So that means one of them's got to be 0, at least one. either x equals -2 or x minus 2 is 0 or x plus 4 is 0 or both. But then you solve for your zeros and you're all set. Only other downside is it's really easy to make small addition and subtraction errors. So for example, if I gave you this problem, let's do this. It's really common that people do something like this, recognizing -5 times 2 is -10, and 5 and 2 do subtract to make 3, but the problem is they have the signs in the wrong place. A good rule of thumb is that the sign on the B goes with the larger value. So the larger value of 5 and 2 is 5, so that sign should go with the 5, leaving the minus sign or the negative sign to go with the 2. Because 5 plus -2 does equal 3, but -5 and +2, as I had it originally, do not add up to 3, they add up to -3. So that's a really easy mistake to make. Okay, and finally, here's how you do each of them. Graphing. If I were given this equation, this would be a tougher one, but I would solve to get the equation equal to 0. Let me just do it all in one step. Taking away the 5x over here and the 35. And now that I have this function equal to 0, I would type this into y equals. It's a minus. I would graph this, and then I would check my graph. The reason I'm going to check my graph is because I might see two solutions. I might see one solution where the vertex is on the x-axis, or I might see no solutions. That's going to give you a little bit of an idea of what to expect when you go to your next step. If you go to second calc zeros and you see no solution, but you're looking at this, you know something went wrong. Whereas if you see no solution, you're looking at this, something probably went right. So after you've checked your graph to kind of get an idea of what you should be looking for, you go second calc zeros, and then it'll ask you for left bound, right bound, and guess. And I would do left bound, right bound, guess for each of the two zeros if there are two zeros. So you do, let me lock in on this one for a sec. You would do like left bound, right bound, guess, and it would give you an answer, like, I don't know, -2.7. It would say this, and you would write x equals -2.7. And then you would do left bound, right bound, guess for this one also. And it would say like 5.82 or something. And you say x equals 5.82. And again, notice those decimals cut off. That's why I kept it. If those went on forever and they were rational numbers, I would immediately stop graphing and I would go do quadratic formula instead. If you see a zero such as ugly number, it's likely an irrational root. So try the quadratic formula instead, because that would be this instead. And these are actually real numbers. So if the quadratic formula gave you this, which is a totally reasonable solution, then the process of graphing would have left you here, which isn't very nice because that got rounded at the end there. Whereas this did not get rounded at all. Okay, that's graphing. Quadratic formula. Get the equation into ax squared plus bx plus c equals 0 form, aka get it equal to 0. So subtract what you need to get there. And now you are plugging this into the quadratic formula, which again, you'll be given. In order to do that, you need an a value, a b value, and a c value. The a value is the coefficient, or the constant value, multiplied by x squared. The b value is the coefficient of the x term, so here that would be -2. And the c value is the constant value, but again, make sure it's on the right side. Make sure it's all equal to 0. When you plug it in, here's the main mistake that people make. Or actually, I guess there's two main mistakes. Mistake number one is plugging in this initial b value. What people do is they see a -b in the front and they're like, oh, cool, that's already taken care of. But the problem is you didn't put -b there. You just put b there. So my recommendation is always to use parentheses around whatever you plug in, because what you should be seeing is negative, and then your B value. If you're a kid that sees that and you're like, that's gross, I'm just going to put positive 2, that is totally fine. I just want people to be in the habit of inputting values for variables and using parentheses. Because the next time you do it, maybe right here, if you're like, oh, I want B, so -2, this would be wrong too. Your calculator is going to read that as negative 2 to the second power is 4. It's going to say that's -4. But it's not. It should be -2 times -2 because B times B. So I would go parentheses around everything you plug in. 4 times A times C all over 2A. You type that entire thing into your calculator and you would click enter, and I believe you get something disgusting. So then you'd be like, oh crap, I don't want something disgusting because something disgusting is a crazy decimal. In fact, let me type it in now. If you don't want to wait for me to type it in, skip like 10 seconds ahead in this video. But I'm going to type it in because you guys deserve that. I'm doing alpha y equals first to build the fraction bar. -2 plus the square root of, parentheses, -2 squared minus 4 times 3 times -17. And then I run down to the bottom, 2 times 3. When I clicked error, it gave me a syntax error. Oh my gosh, that's adorable. I'm just like you guys. Syntax error. Immediately go to, and when you click go to, it'll tell you what's wrong. It gave me this. That's disgusting. That's an irrational number. I want nothing to do with that. If I want the exact roots, here's what I'm going to do instead. I'm going to simplify what I see here. Now, the reason it became irrational is because the discriminant, the inside of that, isn't a perfect square. So what I'm going to do is I'm going to figure out what is that discriminant. Well, -2 to the second power is 4. And 4 times 3 times -17, oh boy, -204. So minus -204 is plus 204. And then I can add together 4 and 204 to get 208. And this would be what I consider right now to be a perfect solution. If you got this, x equals that, I'd be very happy with that. If you're a person that types something like that into Delta Math and you're like, it told me it was wrong, it wasn't simplified enough, here's what it wants. And this is a good part to skip if you don't want to learn ahead. But if you want to learn ahead, here you go. Actually, we did this a little bit. 208 is not only expressed as 208. We can express it in different ways. I could also call that 4 times 52. I could also call that 108 times 4. I could also call that 16 times 13. The nice thing about calling it 16 times 13 or 4 times 52 is that I now have two things inside of multiplications or inside a square root that are multiplied together. What that means is that it's the equivalent of the square root of 16 times the square root of 13. Square root of 16 is 4. So we can call that 4 radical 13 over 6. We did that briefly, like literally for 10 minutes. If you remember it, awesome. If you don't remember it, that's totally okay. But the nice thing there is it allows us to divide everything we got left by 2. So this whole term we can cut in half. This term we can cut in half. This term we can cut in half. And so we can call that 1 plus or minus 2 radical 13 over 3. And that would be like, that's elite. That's like professional level math right there. So quadratic formula, get it equal to 0, plug in A, B, C. Be really careful about how you plug everything in. If it says non-real answer, it means your discriminant is negative and you do have no real answer. But I'm happy with you getting here. So if you get an irrational answer, try and just figure out what is the discriminant and simplify that as far as you can. And then just leave it as something plus or minus that radical over something else. If this is the thing that's totally throwing you over the edge, that's okay. Feel free to use decimals. You would drop a half point because you wouldn't have an exact solution, but it is way, way, way better than having nothing. Okay, completing the square. This one I kind of ran through briefly earlier, so we'll go a little bit more quickly through this. But this is the one where we want x squared to be by itself, so we don't want this 2 here. And we want to kick the constant to the other side. So we would divide everything by 2. We would add the 17. So there's no way this is only a 15-minute video. This is probably so much longer. And now we can split this x coefficient in half. Because like I said earlier, when we expand this out, it'll be x squared minus 8x, so minus 16x, plus 64, which we're happy about because we wanted x squared, we wanted negative 16x, we didn't want this 64. So now we got to fix it. If we added 64 by accident to this side, we've got to add 64 on purpose to this side, leaving us with x minus 8 squared equals 81. Well, now this whole side of the problem is a perfect square, so we can take the square root of the entire thing. Well, the square root of something squared is itself, so we've got x minus 8 left over here, and on the other side, we've got the square root of 81, which is 9 and negative 9. And these are the two equations we can solve to get our 2 zeros. X equals 17 and x equals negative 1. Okay, lastly, factoring. This is the thing we've been doing in class for the last couple days. You are finding, and feel free to read this out, this is like the nice algebraic version. You are finding two values that add to get the b term and multiply to get the c term. Now keep in mind, my equation's already equal to 0. If you had like a 5 on the other side, you'd have to do minus 5 first, and then you could solve it. But mine's already equal to 0 because I wanted my life to be easy. And I really thought this video was going to be like 15 minutes, but it's definitely not. So what you might start to identify are factors of 21. I think it's always easiest to start with this last number before even looking at this. Whatever this last number is, start listing out the factors. It can be 1 times negative 21, or we could flip where the negative is. It could be 3 times negative 7, or we could flip where the negative is. After you've listed out all the factors, which when I say factors, I'm talking about like the nice factors. I'm not talking about like 2 times negative 10.5, even though, yes, I know that that works. When you've listed out all the factors, what you have to do is just start looking for what do these add up to. Negative 20, that's not what I want. Positive 20, still not what I want. Negative 4, ooh, that's what I wanted. So I can use 3 and negative 7 as the way in which I break this apart. Because 3 and negative 7 add up to negative 4, 3 plus negative 7, negative 4, and they multiply to get negative 21. 3 times negative 7 is negative 21. Well, the reason this is nice now is because I have two things, this and this, these two binomials multiply to get 0. Well, if two things multiply to get 0, one of them at least has to be 0. So either x plus 3 is 0 or x minus 7 is 0. And either way, we're happy because the whole product of binomials will be 0. And so that happens when x is negative 3 and when x equals 7. You may have started to notice that the final roots are just the flipped versions of the numbers you used here. That's a great shortcut to memorize. You don't need it, but it does save you a little bit of time. And if you wanted to jump from here to here to here, I'm totally comfortable with that. Even if you skip the middle step and you're feeling ambitious and you just want to jump straight to the answers, go for it. But that's up to you. So at this point, my goal for everybody is that you can, back against the wall, solve for the zeros of a quadratic by graphing, using the quadratic formula, by completing the square, only if you're forced to on a quiz or a test. That is rarely helpful, and by factoring. If any of those 4 things is still like, dude, I cannot do it, I'd really appreciate if you emailed me tonight and I can write you a pass for home base tomorrow and you can come in and we can keep studying them. Because I think with a couple extra examples, all of these can be very doable. Keep in mind, you guys always do better than you expect, and it seems like you always feel not confident until the grades, and then you're always like, oh, okay, I got a 98 after all. So be confident in yourself, study as much as you can. If you didn't finish the Delta Math, that's okay. I'm happy to talk to you about it tomorrow, and let me know if you want to be pulled in for a little bit extra help in the morning. Thanks, guys. Have a great rest of your night.